September 26, 1944, 10:48 p.m., Hanford, Washington. Inside a massive concrete structure along the Columbia River, something unprecedented was about to happen. A graphite cube measuring 28 feet wide, 36 feet long, and approximately 40 feet high sat ready for activation. 1,200 tons of pure graphite, stacked block by precisely machined block. Penetrating through its entire depth were 2004 aluminum tubes loaded with uranium fuel. This wasn't a bomb. This was a factory designed to manufacture something that had never existed in measurable quantities on Earth – Plutonium-239. The Manhattan Project had a uranium bomb design. Scientists were confident about that. But uranium-235 was extraordinarily rare, requiring massive enrichment facilities that might take years to produce enough material for even a handful of weapons. They needed an alternative. They needed plutonium. The problem? In 1942, the entire world's supply of plutonium could fit on the head of a pin. Nobody had ever manufactured it in visible quantities. Nobody knew if it could actually detonate in a weapon. And nobody had any idea how to produce it at industrial scale. The solution required building something never attempted – a production nuclear reactor, not a small experimental pile like Enrico Fermi's successful test in Chicago, but an industrial-scale machine capable of breeding plutonium atoms while simultaneously preventing catastrophic meltdown. This is the story of how engineers solved an impossible problem with 1,200 tons of graphite blocks, 2004 aluminum tubes, and a cooling system that pumped 75,000 gallons of Columbia River water every single minute. This is the story of the B-Reactor at Hanford.
To understand why this graphite cube was necessary, we need to understand what plutonium actually is and why it was so difficult to create. Plutonium-239 doesn't exist naturally in any significant quantity. When uranium-238, the most common uranium isotope, absorbs a neutron, it transforms through radioactive decay into Neptunium-237, which then decays into plutonium-239. This process takes days.